So the next thing that we need to do is we need to worry about definite integrals. So definite integrals, that's when you have a number up top and a number on the bottom. And this is an area, right? And the key idea, the key point is that when you change your variable, you want to change your limits of integration as well. And how do you change your limits of integration? You plug the old limits A and B into your substitution. So if you looked at example 6 over here, we let u be the inside of this function right here, inside of the it's something to the 5th, right? We also see the derivative sitting right here to the side up to a constant, so we know it's going to work. But look what I did. I have my u equal to 1 plus 2x cubed. And then when I want to replace each of these upper limits, I mean the upper limit here and the lower limit here. And the way I do that is I just plug x into my substitution. So when I plug x in, I get a 3 coming out. When I plug 0 in, I get a 1 coming out. And my new limits are from 1 to 3. So once you've done that, you just do everything in terms of u. Because it's a definite integral, we don't want to change back to x. Okay. So let's take a look at example 7 together. We're going to let u be equal to what? Let's do this one more time. Type your answer in the chat box. And then we'll count it down. Ready? Someone jumped the gun here. 3, 2, 1, enter. Good. Oh, Lisa Nick fixed her answer in the intervening time. That's right. I wish that she hadn't fixed her answer so I can make a quick comment. So I'm just going to pretend like she didn't. Let's say you had u equal to 2x. That's not a bad guess, but I want to point out, so when you take du dx, you get 2, right? I want to point out that if you were to include a constant, it doesn't change your derivative at all, because the derivative of a constant is always 0. So we pretty much want to include the constant as long as it's under the square root, if we can, because it's like you get to include it for free. And your integral will become way easier. It'll be square root of u instead of square root of u plus 1. Even for square root of u plus 1, you still need to do another substitution because you can't integrate anything other than square root of a single quantity. So nevertheless, du is equal to dx. We can say dx is equal to 1/2 du. We can make our substitution in a moment. But the whole point over here was that we wanted to change our limits of integration as well. So when we see this dx sitting right here, that's really saying these are x values. These limits of integration are x values. So we want to change those x values to u values. So my x is equal to 4. That tells me that my u is going to be equal to 2 times 4 plus 1, which is 9. My x is equal to 0 means my u is going to be 2 times 0 plus 1, which is equal to 1. Is there any questions about that, my friends? No. Then what does my new integral look like? My new integral goes from 1 to 9, u to the 1/2 power times 1/2 du. That's equal to 1/2 integral from 1 to 9, u to the 1/2 du. That's equal to 1/2 u to the 3/2 times 2/3, evaluated from 1 to 9. I should pause here for a second, make sure no one is lost. Anybody have any questions for me so far?
Oh yeah. Why do we need to plug in x into the original?
Because we are changing the variable to the world of u. So if once I start putting a du over here, my limits of integration need to be expressed in terms of u, not in terms of x.
Okay, so the interval is getting bigger.
Yes. But the integral, but the integrand, the region of integration is getting bigger, but the integrand is also changing. So
Okay.
it's like the whole world is being kind of shifted.
Okay.
Yeah. So I guess the equivalent would be, Steph, have you ever been to Canada?
No,
What about Mexico?
no.
What countries have you been to?
Australia.
Australia works. So like, it's kind of like you're traveling to Australia and you want to buy a pet kangaroo or something. So like changing the variable is like taking our US dollars and switching them to Australian dollars because you're going to Australia. So a kangaroo here might cost you $1,000, but when you go to Australia, it costs you 1,500 Australian dollars. So like we're just making this currency conversion when we go to Australia. Changing the variables like going to Australia, and we need to change the prices of things from US dollars to Australian dollars. And then we're making our purchase there. So that's kind of the idea.
Okay, got it. Thank you.
I now need to finish this problem. So this is going to be 1/3 times 9 to the 3/2 minus 1/3 times 1 to the 3/2. The way I've taught you to do this is we can write 9 to the 3/2 as 9 to the 1/2 cubed, and 9 to the 1/2 is just 3. So it'd be 3 cubed, which is 27. But we're dividing by 3 still, right? So that's 27 minus 27 divided by 3 is 9. And then 1 to the 3/2 power is just 1, so that's 9 minus 1/3, which is 26 over 3. Is there any questions about this?